Very good morning, everyone. Today's our topic is relays and circuit breaker, which are very essential in giving protection to the total power systems. They will be coordinating with the different faults which are existing in the power system, either in natural or artificial. When out of these two, relay is an intelligent device, whereas circuit breaker will be taking command from the relay and operates and will isolate the faulty device from the healthy device. So coming in deep, relay, first we'll discuss the relay. Um, so here the sequence follows like this. It's introduction and different types of relays and relays operation principle and circuit breaker operation principle and its applications, advantages, disadvantages. So, coming to the introduction, relay is an electrical device which is designed to initiate isolation of the part of an electrical installation or to give an alarm signal to the circuit breaker for an abnormal condition or faults. So it will be divided based on its operation and its nature of action. It is divided into two types, that is primary relays and secondary relays or backup relays. Relay's malfunction is due to the opening of the circuit breaker, open circuit and trip coil failure and short circuit conditions in the relay, and it will no longer, when the mal-operation of the relay is take place, it will no longer give signal to the circuit breaker. So we have, based on its operation, that is primary relays will be like a primary protection for the total entire system, which will be acting in a first response to the when fault exists in the system. And when primary relays failure, secondary relays will be acting like a backup. They will be acting like a backup, and they will act accordingly and give signal to the circuit breaker. So see, we have the complexified power system in the existing in the which is existing in our system. So like this. So what is the solution if any fault occurs in the system? So solution will be the relay, our protection system mainly depends upon the sensing elements which are existing in the relay. That relay will give signals to the circuit breaker. Here, if you see this, A will be like signal. A will be like signal which is equivalent to the relay, and B will be acting as per the signal given by the A, and B is just nothing but circuit breaker. So this is how the total system will be acting like. So consider here in the consider the total system. Here the person who wants to watch TV will be giving signal through the remote control, and even the power supply is there, but TV is not in the switch on position because of the not closing the circuit contacts. The contacts of the circuit will be closed only when they receive signal from the remote, that is like a relay. So here A will give signal to the B in order to operate, and B will be acting on it. So B will be closing the contacts and the TV will be on. Whenever he wants, A don't want to watch the TV, and he will off the signal with the help of remote control, which is like similar condition of a relay, and B will be on off position. So this is how the total system will be acting on. So this the world of relay, because of the relays and the very fine sensitive protection in the given by the relay system with the help of sensing elements, we have different equipments which are generating in our electrical systems. So very complex systems can be identified, and they will be given protection with the help of the relays. So the basic relay operation will be like this. So it will first sense it is having three types of elements, that is sensing element, comparison element, and control element. So sensing element will have the different parameters like frequency, voltage, current, and power factor, and different types of electrical parameters. When the so it will sense the existing condition of the power system power, and it will give to the comparison element. In the comparison element, already predefined parameters are injected. So when the sensing element parameter is more is more than the existing parameters, then it will be treating it like a fault, and that fault signal will be given by the control, give to the control element. Then control element will give signal to the trip circuit. Then the trip circuit will be giving signal to the circuit breaker, and circuit breaker contacts will open. Therefore, the faulty system which is present in the abnormal, which is present like an abnormal condition, that will be open, and the faulty system will be isolated from the healthy system. Like this, the basic operation of the relay will be acting like. So here the trip circuit is having, say, this is like an electromagnetic signal. So when a signal is when a signal is applied to the magnetic field, then it will generate the magnetic field and closes the switch because of the because of the current flowing through the coil wires given by the signal from the relay. The switch will be attracted by the magnetic field and the switch will be closing. So when there is no signal given to the trip circuit, then for no current will be taking place, therefore the switch is in open condition. So this is how the operation of the relay will be taking place. So like this is how it will be acting like upon. So when a signal is given to the trip circuit, when a signal is given to the trip circuit, so this is how, when a signal is given to the trip circuit, then it will have the current, and the current will be attracting the this particular bob, and it will close and it will come downwards. So when it come downwards, it will be it will be like a closed circuit, closed contact. It will be like closed contact. Then the signal will be given to the circuit breaker. Circuit breaker will be opening the contacts. So this is how the total system will be running. So here the protective relay will be acting upon. um, so protective relay is nothing but it will have the different types of quantities which are predefinedly in the control element, comparison element, that is condition of current, voltage, phase angle, frequency. When the abnormal condition is detecting in the system with comparison to the existing parameters, then the relay will be considered there is a fault inside the system. Therefore, that fault signal will be given to the circuit breaker through the trip circuit. So the circuit breaker will be acting accordingly. So this is how the protective relay will be like given to. So when there is a fault in the feeder, therefore that will be given to the current transformer. The current transformer will be uh, having an input of the fault current. Therefore the secondary of the current transformer will be increasing gradually because of the magnetic flux which is generated through the secondary coil will be attracting this particular magnet downwards. Therefore the trip coil will be energized. The trip coil will be energizing the circuit breaker, and the circuit breaker contacts will open. Therefore the line, whatever the line is existing in the power system, that will be isolated from the faulty system. This is how the protective typical relay will be acting like upon. So the primary and basic requirements of the relays are, that is sensitivity and discrimination, speed, sense, reliability, simplicity, economy. These are the 5 different characteristics one relay should have, because selectivity and discrimination. Selectivity means the required quantity, whether the relay should be acted upon with the having the input of voltage or current or frequency. So it should select the particular component, and it will be discriminating whether it will be like under voltage relay or over voltage relay or under current relay or over frequency relay or over speed relay, like that. The discrimination will be selection, and discrimination need to be taken care when we select the particular relay. And speed of operation, whether the relay will be operating exponential to the like a very high speed operation or low speed operation. It needs some time delay, or it needs very high time delay. Like that, the speed will be is one of the criteria by selecting the relay. And sensitivity means minute change in the existing system will be giving signal to the trip circuit, and the trip circuit will give signal to the circuit breaker. That is how the sensitive or if majority of change need to be considered, or minute change need to be considered, like that type of selection criteria will be based on the sensitivity parameter. And reliability, how best the relay will be operating within the given conditions and how accurately it is operating. That is how the reliability, one should trust the relay. So the working condition of the relay, and under abnormal operation, we cannot define the circumstances over there, that is the temperature or pressure or so like different atmospheric conditions. So all these need to be withstand by the relay, and relay should do its job. Then only it will be more reliable. And simplicity, the construction need to be very simple and robust, because it need to be operated under extreme conditions, that is faulty conditions. Therefore it should be simple, and also it should be robust in structure. Economy, the cost is also one of the criteria. As per the standards, 5% of the total system need to be 5% of the total system cost need to be defined to the protection purpose. So out of that budget only we need to manufacture the relay, and we need to select the relay. These are the requirements and characteristics of the relay should possess. So there are some important terms which are related to the relay, that is operating force or torque. So operating force or torque means that is amount of force that is required for the trip circuit to close it and give signal to the circuit breaker. That is nothing but the operating force. That the operating force is nothing but it is the driving force. Driving force for the relay to operate is nothing but operating force or torque. And restraining force means when the system is under normal condition, that means current will be flowing through the trip circuit, and trip circuit will generate the magnetic flux. Because of the magnetic, the trip circuit moving contact should not close. It is having some spring like structure. That spring is having some force which will be overcoming the attraction force under normal conditions, and it will be overcome the attraction force only under abnormal condition. So under normal condition, without having the operation, is nothing but the restraining force. And operating or pickup level, that is the threshold value, the point of overcoming the force, the particular force when we will just overcome, that is called the pickup level. The point of operation of the trip circuit is nothing but the pickup level, the voltage level at which that particular trip circuit will act, that is the threshold voltage level, or current threshold current level, or threshold frequency level. So those are the nothing but operating or pickup levels. And dropout or reset levels, when the system is performed its operation under faulty condition, after clearing the fault, again it should come back to its original position, that is dropout or reset level. That is given by the parameter dropout or reset level. Flag is nothing but it is the operation of the relay, or the parameters of the relay is indicated by the flag or target terminology. And burden, whatever the power is consumed by that particular relay to operate, is nothing but the burden of that relay. It is also an additional burden to the system because it will consume some power to operate. And operating time, the time of operation is defined by this particular terminology, that is operating time, whether it is extremely inverse or proportional or directly proportional. So those operating parameters is given by the term operating time. And overreach, that is the relay is set to overreach when it operates for a current which is lower than its setting. That means that is more sensitive. Whatever the quantities given for the relay to operate, if it is operating below the quantities, then it is set to be overreach. And current setting is nothing but the prescribed level. The comparison element is having the predefined parameters. Those parameters are given with the help of the current setting, that is at what current level the relay need to operate, at what current level the relay trip circuit need to close, at what current level the relay should give signal to the circuit breaker. This is given by the terminology current setting. So based on the different types of operation and the term that selection criteria and selectivity, sensitivity, reliability. So relays are classified into say 8 different types. That is armature, attracted armature type of relay based on the principle and the construction. If the construction involves a magnetic part and electromagnetic part and iron and complete mechanical structure, then it is given by the terminology called attracted armature type relays. These are used for the overcurrent protection, differential protection, auxiliary relays, definite time lag overcurrent, and earth fault protection. So for this purpose, the attracted armature type relays will be using. Static relays, when the relays is having the electronic components, that is a that is diodes and transistors and BJTs and MOSFETs. So then the static relays will be classified based on the electronic components which are used in the operation of the relay. And microprocessor controlled relays, when the microprocessor is a key role to play like a control element and comparison element, then it is said to be microprocessor relays. So under voltage relays, the voltage that means when the relay is operating, if the voltage level is very less when compared to the prescribed normal voltage level, then it is said to be under voltage relays. So overcurrent protection, like with the if the current is very much high when compared to the normal condition, then the relay will operate. That is given by the overcurrent protection. In overcurrent protection, based on its characteristics, we have 5 different types of relays. That is definite overcurrent relay, inverse overcurrent relay, extremely inverse overcurrent relay, very inverse overcurrent relay, inverse overcurrent relay. So these are the different types of overcurrent relays based on its time of operation when the current level is more than the normal level. So differential relays means when two quantities, when the input quantity and output quantity are compared, if that comparison is having no difference, then it is said to be no difference. The system is in perfect condition. If there is a difference from the output and input quantity, then the relay is having some difference, which leads to the comparison element acting to the give signals to the control element, and control element gives signals to the trip circuit gives signals to the circuit breaker. So based on this principle, the differential relays operates. The differential relays is having the 4 different types, that is the voltage balance differential relay, percentage differential relay, and current differential relay. And the distance relay, 7th one is the distance relay. Distance relays, like based by taking the distance of the protection which need to be like in the transmission or total power system, that total distance, whenever there is any fault, that total is taken care by the distance relays. And impedance relay, based on the impedance parameter, if the relay is acting upon, then it is said to be impedance relays. So these are the this is the overview of the relays in a power system. And if you go for the circuit breakers, circuit breaker is a slave which will take command from the relay and will make the circuit or break the circuit based on the instruction given from the relay. So it is protect the circuit by interrupting the current flowing in the line by opening the contacts. Okay, so when the opening of the contacts are taking place, there will be isolation of the healthy system from the faulty system. So we are having so the circuit breaker is having the different types of constructional features. That is, it is having electromagnet, that are bimetallic strip, moving contact, switch, stationary contact, upper and lower terminal, and catch. These are the few simple components which are present in the circuit breaker. Basically, circuit breaker is consisting of a simple switch which is connected to either an electromagnet or bimetallic strip. That is, when the current reaches its abnormal levels, then the bimetallic strip or electromagnet will be strong enough to pull down the moving contact, and therefore the circuit will open. Because of this, the faulty portion will be terminated from the healthy section. This is the layout of the circuit breaker, which is shown in figure. Here we can see the moving contact, stationary contact, and terminals, and switch, catch, electromagnet, and terminals. So this is the layout of the circuit breaker, that is which are practically existing. So here, based on the when a circuit breaker is operating, that is, it is tripping the circuit from the healthy section to the faulty section. The outcome is there will be an arc which is present during the time of operation. The arc need to be quenched, because sudden charge and discharge of the material is not possible. So we will be experiencing the byproduct when the operation of the circuit breaker is arc. That arc need to be quenched. So based on the different types of mediums, the arc will be taken care of. Based on the mediums we are using in the circuit breaker, the circuit breakers are classified into 4 types. That is oil circuit breaker or minimum oil circuit breaker, air blast circuit breaker, SF6 circuit breaker, and vacuum circuit breaker. That means if with the help of the minimum oil, if the arc in the circuit breaker is quenched at the time of operation, then it is classified as the oil circuit breaker. If we quench the arc by using air, then it is said to be air blast circuit breaker. If we quench the arc by using SF6 medium, then it is called SF6 circuit breaker. If we quench the arc with the help of vacuum, then it is called vacuum circuit breaker. So the characteristics of the circuit breakers will be, it should perform the interruption function only, because it is a completely it is completely classified like a slave which takes command from the relay. Therefore, whenever the signal comes from the relay, it should act. So it will perform the interruption function only when the signal is detecting from the relay system. It can requires relays for automatic action. So by automatic action, that means when the fault is existing in the system which is sensed by the relay, it need to be operated. When the fault is not present in the system which is sensed by the relay, it should make the circuit. So make and break the circuit need to be taken care by the circuit breaker. It should be larger in size, because in order to quench the arc and give sufficient path for the flow of arc um, and to take care of the faulty current, it should be larger in size. And operating time is comparatively large, that is 0.1 to 0.2 seconds. No need for replacement after operation. No need to replacement after operation. Like if you consider fuse systems which will be acting when there is any faulty currents in the system, the fuse will be burning. After the burning of the fuse, we need to replace it again. It will take some time. But in case of circuit breaker, it will take only 0.1 to 0.2 seconds, and after the system is in healthy condition, it can be no need to replace the total circuit breaker. It need to be reset again. So this is how the total circuit breaker characteristics are been presented here with the construction and its silent features and its operation. So thank you for giving this opportunity.